Welcome everyone to today's webinar, Optimizing Drone Applications for Disease Management. My name is Laura Isles. I'm one of the co-directors of the North Central IPM Center. We're one of 4 regional IPM centers supported by the USDA NIFA Crop Protection and Pest Management Regional Coordination Program. We have a mission to coordinate IPM across the region by sharing and promoting IPM research, extension, and teaching activities. During today's webinar, if you have any questions, please type them in the Q&A part at the bottom of your Zoom screen, and our speakers will answer all the questions at the end of the presentation. So today I'm very excited to introduce Darcy Telenko from Purdue University and Kirsten Wise from University of Kentucky to share with us information on optimizing drone applications for disease management. So I'll let you take it away.
Okay, well, thank you, Laura. We appreciate the invitation today. So Kirsten and I are going to talk a little bit about some of our research that we've had on looking at drone applications and hopefully maybe give you some ideas to think about if you're thinking about looking at drone applications for use on your farm. As we think about integrated disease management in field crops, I just want to review a few things about disease management first before we really jump into using drones. And as always, as an extension plant pathologist, I got to remind you of the disease triangle, and I see Kirsten laughing at me. But it's important to know that, we have the susceptible host there and a virulent pathogen. But the big thing to understand is what's the favorable environment. And I know that's the question I get from my guys here in Indiana. What do we need to do in July with some of these diseases? And I'm always reminded I still don't know what the weather looks like this weekend. I can't tell you what, the weather conditions will be in July. But, we need that favorable environment to increase our disease risk. And if that environment isn't favorable, then maybe the risk is low and maybe we won't need a fungicide in season, especially if commodity prices are low. Then there are the times when we have that optimum conditions and, the disease risk is going to go up. And so that's what really will dictate whether a fungicide is needed. If I'm thinking about using foliar fungicides, I think about these main targets, and there's probably a few I'm missing, but I listed about 4 for each of the crops. So in corn, gray leaf spot, northern corn leaf blight, southern rust, and tar spot. Maybe if in the south, you may have a few other diseases. Soybean here in Indiana, generally, we're looking for frog eye leaf spot and white mold control if we're going to use a fungicide to control diseases, but Cercospora leaf blight and Septaria brown spot are also out there. I don't know, Kirsten, do you think of any others that I've missed?
Those are the big ones. I think those are really what we're trying to target with a lot of our applications, right?
Correct. And as a plant pathologist, my goal is not only protecting yields, but also managing disease. I want a two-pass thing. I want to control the disease and protect yields when I'm looking at using a fungicide. And so just as a reminder, what some of these diseases look like, gray leaf spot on corn can be found anywhere in that canopy, but generally we're watching for the lower leaves if it's appearing first to make a decision. Northern corn leaf blight may appear anywhere in the canopy, those cigar-shaped lesions. We do monitor for southern rust in corn. Generally here in Indiana, I'm watching what's going on in Kentucky first to see if we need to really worry about it in southern Indiana. We start the slate clean every year. So we'll see what happens with that one. And then the big one I've been dealing with a lot is tar spot. And just a little reminder on that disease, there is time to find it here in Indiana and in those states that have had the issue in the lower canopy, and to make an informed decision if we need to start spraying as the crop reaches VT tassel silking stages. But that's another talk for another day. If we look at soybean diseases, again, frog eye leaf spot is probably the main target for using a foliar fungicide in soybean. While we're spraying, we may also see Cercospora leaf blight that causes these bronzing discoloration in the leaves, Septoria brown spots generally in the lower canopy. And then sometimes if they're in areas that have a white mold problem, we got to target flowering for our fungicides for white mold. So in general, those are the 8 diseases I look at here in Indiana, and probably Kirsten's looking at in Kentucky for using a foliar fungicides in our crop. If you're trying to determine what products, and we're not really going to get into that today, there are some really good resources available on the Crop Protection Network. Both the fungicide efficacy tables for corn and soybean have been updated as of February. So they're both there with some, I think both of them have some new products on them. There's also a wheat efficacy table. If you need resources on wheat, that's probably the first thing that we need to think about putting any fungicides out in the next couple of weeks or months or so. But again, if you're trying to determine what products, these are great resources to try to hone in on what you may want to use when we now talk about the tools that we can apply them on. And so I guess when we're looking at putting out foliar fungicides, generally we're thinking here in Indiana, we may be putting it out with ground equipment, putting in applications at 15 to 20 gallons per acre. Airplanes and helicopters may be coming in at 2 to 5 gallons per acre. And now we have that fourth option using drones. And so some of our work, we've been looking at that 2 to 5 range to see what that'll impact on our disease control. But before we get started, I thought I'd review a little bit on drone history and usage. And if you haven't seen this, there's a really good book, and I'm going to pull some of the information out of this book that they've put together on spray drones. It has a lot of useful information on how spray drones have evolved over time, and then things to think about. And I still think a lot of these will when we get to the end of the talk, still remain true on the things we need to think about on if we're going to use a spray drone for putting out fungicides. The unique thing, and I've pulled some of these images from the book, is just thinking about where we're going with the drones. So, 5 years ago, we were mainly using drones to take images of our fields, right? And in addition to field images and assessing what's going on in the crop, there's also these other uses that drones have been used for imaging around the country, looking at utilities, emergencies, imaging, wildfires, and other things. So there's been all these additional uses beyond ag for using drones beyond the farm. But if we look at now, we're switching gears, right? And looking at why would we want to switch to spray drones versus our ground equipment or trying to get in the airplanes or helicopters. And I think that this kind of demonstrates some of those things that we're thinking about. Maybe we can have more targeted sprays, get in when we can't get into the field, maybe because conditions are too wet for a ground application. There's maybe less water used than our ground sprayers, maybe less mechanically easier to operate, maybe a lower cost in even just purchasing a drone versus a ground equipment. We can avoid those obstacles and spray in those fields that have odd shapes or tree lines. And maybe, in addition, we can maybe reduce some of our pesticide applications if we can target sprays within a field versus having to run across the whole area. So kind of the idea of some of the upsides of why we think we want to move to spray drones or use spray drones on farm. The other side of it, though, is you need to think about the downside of the spray drones. And a lot of these is really, as we've learned over time, as we continue to pull these in and learn them in our system, some of the things we may look at. Maybe there's a short service life on the drones. I mean, since we started a few years ago, the types of drones we're using keeps changing and we can't keep up keeping the drones going. Our pesticide labels, I mean, this is the one thing I really want to emphasize is we really need to read our labels closely and see if there may not be any information for drone use. And then are there restrictions we need to keep in mind if we're going to use those pesticide products on, amount of product, gallons per acre we have to spray at a minimum. Are there notations on aerial application that we need to follow? We still see spray drift as a concern. So again, we got to think about the environmental conditions that we're spraying in. To get drones operating and to cover as much land area as our ground equipment or airplanes, again, that could be labor intensive and making sure we have enough batteries on site to keep the drone charged. Regulations, they're constantly changing, but they're becoming more complex than our ground applications. We always have to keep an eye on the drone. So if we're spraying corn, again, you got to have a platform or something so you can see that drone as it's moving through a field. And I would say so on our side, we're still limited on the amount of research we can provide on how drones compare to using ground equipment or other things. And we'll talk a little bit of what we've been learning here in a few minutes. One thing that we've noticed that's changed a lot, and I guess in the last couple of years, is the switching of the nozzles that were available. So initially, most of our drones started with our standard nozzles that we use on our ground equipment, looking at the XR nozzle on the left. But now the newer drones coming out have these rotary atomizers that are being used. And so that comes into the question on what does our droplet size look like and how well is it penetrating and staying in that crop canopy? In addition to that drone research, I would say there's a really good resource that Fred Whitford wrote about spray nozzles. So it's mainly covering all the spray nozzles up to those rotary atomizers. But again, looking at some of those things that there's all this research on why we select different spray nozzles for different application techniques. So again, those are some of the changes that continue to change as we move along and looking at using spray drones. Am I missing anything yet, Kirsten?
No, that's good.
Okay. And so the big thing we're looking at is, looking at spray deposition. And I think this is the really big thing that anyone that's looking to add a spray drone to their farm really needs to understand this pattern and how wide is the swath width actually being sprayed versus the marketability of, they say it could spray 30 feet. Are we really getting 30 feet, or is the actual really 20 or 25? So again, we've been doing a lot of work here at Purdue in a number of programs. The weed science program has done a lot of work on looking how do we monitor and evaluate spray deposition across the boom width. And again, there's different ways. There's a swath gobbler that can look at dye sprayed across a piece of paper, and then there's different types of paper that we can use to evaluate how the spray is being, how the droplets are reaching that crop canopy. In addition to that, I think it's important if you're looking at drones and adding them to the farm, you need to follow all the state and federal requirements. In Indiana here, you need to follow the federal laws and being able just to fly the drone. And then Indiana, and for Indiana, there's a written test every 24 months. And think about, you also need insurance if you're flying it for profit. In addition, you got to have not only be able to fly the drone with the federal laws with the FAA, you also need to have a licensed pesticide applicator application. And that also includes an additional area application license to that core exam. So you got to have 2 licenses in order to put pesticides out through our drones. There is a nice resource there, a link on all the regulatory information. There's a couple different sites to go to try to look at that. And then I'm going to ask Kirsten maybe to explain what's required in Kentucky.
And it's very similar to Indiana. The most important is you have to follow the FAA requirements, the federal laws. The Kentucky Department of Ag has their own requirements that have to be met. They also, in Kentucky, you have to be a pesticide applicator and also an aerial applicator. So you have to have those 2 different licenses. Probably the one big difference is that depending on what you are spraying with your drone, you may need additional licensures. So if you're just spraying crops, but if you're spraying any forests or aquatic areas or right-of-ways, which is another one with the drones that get used a lot, those do require additional licenses in Kentucky. And so it's really important to know what's required in your state and make sure you have all of those licenses and are following all of the guidelines.
Yep. And I would say if you're not in Indiana, Kentucky, there's also a resource there to kind of give you an idea where the regulatory agencies are on trying to see what's the requirements for your individual state. I also just want to remind you, the federal pesticide label is the law, so you need to make sure you're following all those when you're applying it, even with a drone. And the big one is making sure you have the minimum GPA coming out of the drone, and then any application restrictions that are part of that license must also be, or that pesticide label must also be followed. And so looking at here in Indiana, we've done research now in a couple of years, looking at the drones compared to ground equipment. And luckily we have a nice resource here in Indiana where we have extension educators that actually had drone licenses. They've been flying the drones for image data collection, but then also some of those have also expanded and gotten pesticide capabilities. And so we have a set of drones that we can use to apply pesticides on some of our Purdue farms. So we teamed up with them and kind of asked a few questions on how are fungicides, how are they going to work? Are they going to provide the disease control we need? And so we had 4 different sites where we looked at our ground equipment versus a drone. At some of the larger farms, we were able to run drones at 2 gallons per acre versus 5 gallons per acre, compared to their farm ground equipment at 15 to 20, depending on the farm. And then we also layered in, if there was space in some of those field scale trials, an application at R3 for soybeans per se, and then R5 a little later in soybeans. And then at corn, we also ran it at VT and then R3 as well. So we tried to compare both soybeans and corn and how do these applications look when we're trying to look at disease control. In these trials, generally we had Veltima with an NAS or standard application at 7 fluid ounces an acre, and soybean we used Delaro Complete. And again, we had 4 different farms, and each farm was a little different on what we used. And this research was supported by both our Indiana corn and Indiana soybean resources. So as we were getting into this and learning as we were going along, we tried to monitor spray deposition within the crop canopy. And so what we mainly targeted was what the center of the plot, the center of the drone or the center of the spray equipment, what was our deposition within that crop canopy in the corn or soybeans. We started with moisture sensitive papers. They don't work very well in beans, and they're harder to get. You got to run right out and get them. We ended up switching last year to the ChromaCoat paper, and I'll show some of that data. And then we put a dye into the system. So we have either a blue or red pink dye that is sprayed out. And then others have also looked at PST, an acid, and collecting leaves and washing that area and quantifying the amount of product off. And I think, Kirsten, that's some of the work you've done. And then I don't do the swath gobbler because we're in canopy. And so the swath gobbler really needs to be on the ground to get it to work. But I know our weed science team has used the swath gobbler to kind of evaluate how does it look along the whole swath as we're using our drones. And then in addition to that, we did the disease assessment and yield in some of these trials. And so that's the data I'm going to share here today to see where we are. So again, we had 3 field scale locations that we've run across the state. So Northern Indiana, Central Indiana, and Southern Indiana. At Davis Pack, we had a Patriot sprayer with a 30-foot boom. At NEPAC, we had a Case IH sprayer with a 30-foot boom. And then at CPAC, we had Apache. So we had 3 different ground rigs that we were comparing to. Those farms, we used a DJI T30 drone that had about a 16, I think. What is it? Where am I losing my, can't see. Spray width, or 15 to 16 foot spray width is what we were looking at. But again, we targeted center of the boom, or center of that spray pattern. We were able to slow it down. So we did try to achieve a 2 gallons per acre versus 5 gallons per acre spray application time. So when we slow that drone down, that means it's going to take a lot longer time for it to get across the field. But the question is, do we need more gallons to get that canopy penetrated? And then in Penny, Purdue, that's where our tar spot work is. And so we had a small plot location set up where we compared our spider sprayer to a CO2 backpack, if we had a backpack, as we do in some small plot research. And then we had a T10 drone there, so it could spray just 4 rows for us at a time. And that one was about 1.65 gallons per acre when we used that. In each of those plots, again, we scanned cards and then looked at the disease data. And so that's what I'm going to share next here. Again, these are the 2 drones that we've been using here in Indiana, and I know they're switching to different drones that have the atomatizers, but we have right now, these ones had nozzles on them. So that T30 had a 16 nozzles on it that sprayed at their main farms. And then the T10 had 4 nozzles on that one. And so this is just an example here of last year spraying at one of our farms. I thought I'd just share. Here we got a drone that's imaging the drone that's spraying across the field. So you can kind of see the blue dye that we added to the spray to try to document and see how far that spray penetration was going into the crop canopy. And so from the water sensitive paper, and this is where we've switched a little bit, but it does give a better idea, especially in the corn, of where the spray drops are landing. And one question we had initially, and so we actually put the paper on the leaves of corn. And so we did the middle leaf, the ear leaf, and then we did 2 leaves above and 2 leaves below. And we put a piece of paper on the top and the bottom of the leaf. And as you look at these little spray droplets, you can kind of see, in the middle canopy, let's see, where am I? Ear leaf here. So the top of the canopy had a lot more spray droplets. If I got this laid out right. But most of the droplets were being caught on the top of the leaf and not the underside. And I know Kirsten's seen the same thing, but our droplets are on the top of the leaf. But if we talk about disease management, that's probably where we need to be with our fungicide. So that's okay. And you can kind of see the dissipation on the coverage. So I think it's top to bottom. So that this top row here is the top of the canopy. And then we go down into the middle of the canopy, which is where I want to target leaf protection. And then the lower part of the canopy there with the water sensitive paper. We switched this last year to the ChromaCard cards. We actually set up our mock corn plant with the the different canopy areas to kind of look at where the deposition was occurring. So again, you can see more deposition in the upper canopy. Middle canopy has generally a good deposition on those top of the leaves. And then we lose deposition as we reach the bottom of the canopy, which is normally expected as we move along. But again, this is the kind of the different things we see. You can actually see here, you know, ground rig had higher deposition. The drones at 5 gallons per acre, you know, a little less. And then, you know, when we go to 2 gallons per acre, there's still some deposition there. You can see the coloring, but you know, we've sped up the machine and less gallons per acre. So we quantified this. And so here's an example of looking at that coverage of that card, percent coverage of the card by the different pieces of equipment. So you can see our non-treated had very little, no deposition. The drones, again, you can kind of see the filled in bars are the ones at the top of the leaf versus the ones you can't see are the lower side of the leaf. So the drone with 2 gallons per acre had a little bit more coverage, but then you can see when we slowed down to 5 gallons per acre, we had actually more coverage at Davis with the drone versus our ground rig in that canopy. So that was kind of interesting that we had so much coverage in that upper part of the canopy when we slowed the drone down to 5 gallons per acre. If we look at Penny, and this is where we had the backpack in addition to our ground rig and just drone at 1.6 gallons per acre. Again, you can see, you know, as expected, the backpack and ground rig had higher deposition in that upper, the green bars, and the middle yellow bar of the canopy compared to the drone at 1.6 gallons per acre. So again, you can kind of see these depending on how much water you're putting through the canopy. You know, we will see, you know, the changes in the deposition, but the question comes into mind, how is the product, how much of the product is there and controlling diseases? Like, so that's the main point for me is, how are we getting disease control for that? And when I talk to growers, I guess my one thing when you're looking at all these pieces of equipment and trying to evaluate what's best to your farm, you also need to take in consideration what the disease level is. And so if our disease level is really low, they're all going to look alike and look the same and look good to you. It's when I worry when we have high disease pressure. And I'm going to acknowledge that right now in these last couple of years, we really didn't get a lot of disease pressure, where I'm not quite there yet to say, when I have severe tar spot, it's going to hold on, because I've seen fields where we've had striping and things occur where we're not getting a good coverage. But from this data in 2024, we in Southeast Indiana had tar spot, gray leaf spot, and rust. And as you can see from the data, actually all ways we applied it, so the drone at 2 gallons per acre, 5 gallons per acre was similar to the ground rig. So at that low disease level, it looks really good on reducing disease over not treating with a fungicide. If we move to middle of Indiana, so our Davis Center, there we had tar spot and northern chlorine leaf blight. And again, all 3 applications did reduce disease over the non-treated. But what was unique in this trial, and this was something unique that popped up that we hadn't seen previously, is that 5 gallon per acre drone application actually significantly reduced tar spot compared to my ground rig application. And I kind of like that idea, because if tar spot gets really severe, we do want more canopy penetration and more quantity. If I go back to that slide I showed you, that was the one that had a lot more penetration and coverage within that canopy. So that's some good news there. Maybe we need to slow the drone down, especially if we're targeting a disease like tar spot, whereas northern chlorine leaf blight really didn't have a difference between the applications. And then finally, I'm gonna have to move this. If we look at up at Penny, where we had a lot more tar spot, again, you can kind of see where, and so the drone I would say is on the gallons per acre or less than I really would want to be, that we could go with at T10. You can actually see, you know, the backpack and the ground rig were better at getting the coverage in there at Penny, where we had higher disease pressure. So again, data that's coming off, and we'll be running these trials again this next year to kind of see where we land and the disease pressure. But again, if we look at it, DPAC, you know, saw that 5 gallons per acre reduced the disease and for tar spot versus that 20. And that Penny, we actually got pretty good with our 15 gallons per acre versus the drone at 1.6. Then the big question comes to me is, what is the effect on yield? I mean, that's what the main thing is. What is a return on spraying these fungicides and get us that yield? Because disease pressure was low, we didn't see any yield effect up in Southeast Indiana. But Davis, again, the yields were flat. but at Penny, where we had that severe tar spot, actually, those two, the backpack and the ground rig, where we had better disease control, we did see a positive net return with yield. So again, the whole point is making sure when we have high disease pressure, do we have the product there to manage it? And this is where if we drop the gallons per acre there on the drone, maybe we may not get the coverage we need for tar spot at least.
So Darcy, I learned that we need to backpack everything on. That's what I just learned.
No, I am not doing that. I'm going to stick with the ground rig, but I'm just saying, because we backpack some things, we just wanted to see what the backpack
Right.
change, right? Yeah, no, not going to backpack, but I like the gallons per acre if we can get it in the ground rig. And so I know some may jump it up to 20. And so some of our farms, we did have 20 versus 15, but this isn't, and hopefully down the line, we'll have more data to show, tar spot's the one disease that's going to show you how much coverage you had, and any leaf that's not protected is going to have the disease. So that's something you can keep an eye on. And then, so switching to beans. So this is an example of where we were spraying with a T30 on our soybeans. Again, you can kind of see the dye that we have in the drone to try to capture that on our chroma cards. Oops. And so again, I just want to show this is where that it's the canopy's too wet in the beans to really use this moisture sensitive paper. So we learned as we go along, but you can kind of see, the ground rig there worked real well. And then I think the soybean canopy got a little wet there to really make any assessments on that coverage. So that's kind of why we switched to the dyes. If we look at the spray dyes here, again, you can kind of see, ground rig, we can kind of see at the top in the middle, we have good coverage. And then the drone, 5 gallons per acre, we see the drop off, but the question is how much can we handle and get good disease control? And so again, similar results. Again, everything on the top of the leaf got the product and coverage, and the bottom of the leaf really didn't register any. There's a few that we see once in a while, we might see it. And again, same kind of staggered effect. The ground rig at 20 gallons per acre in the upper canopy had the highest coverage, and it goes down from there. And we pretty much saw the same results in all the locations. Depending on the location, maybe the ground rig was a little bit more than others, but again, similar results. We increased the gallons per acre, we increased the coverage within that canopy, particularly at the top and the middle part of that canopy. If we look at disease, at Southeast Purdue, we actually had Septoria brown spot. So that, if you think about where that disease is, it's in the lower canopy. So the question is, how far in the canopy did we get to control disease? And as you can see here, I don't have any significance. I don't have any ABs on that. So there was no significance at even applying for control. It wasn't any better than the non-treated control at CPAC. If we look at the Northeast Ag Center, we had both a little bit of frog eye and Septoria, but again, lower canopy, the disease is less than 2%, really no effect on diseases. We really didn't need to treat for foliar diseases in my mind at those two locations. But what was unique is if we look at Davis, they actually had both Septoria and some frog eye. We didn't see a significant effect on Septoria again in the lower canopy, but the frog eye, we do see that all applications significantly reduced frog eye in that crop canopy. So that's a bonus if we had enough disease to really look at it. But again, all that we had enough coverage by all those applications at all those two different timings that we had to reduce frog eye leaf spots. So again, that's important, is think where the disease is and where do we got to reach it. So if we're looking at, I think about frog eye, so I really want to cover the top of the canopy. White mold would be another question. And we have colleagues that are probably working on that, because that generally we want coverage underneath that canopy to slow down white mold. So the question of using drones for white mold, it may be a different answer versus if we use it for frog eye. But again, no difference in those applications for reducing frog eye at that one location where we had disease. If we look at yield though, because disease pressure is low, my soybean yields were flat. And so then I'm going to go back and put my little plant pathology hat on and say, maybe this is a year we really didn't need to spray a fungicide for foliar diseases in soybeans because the disease pressure was really low. But again, we'll keep looking at this. And if we have an outbreak of one of the diseases, maybe we'll be able to determine which application may be better, or they all may work the same. So then you can pick and choose what equipment you want to use on your farm. So kind of a summary of what we've been seeing in Indiana. Depositions mainly occurring on the upper leaf surface. The top of the canopy in both corn and soybean has the highest level of the deposition. When we have low disease pressure, no significant differences between application equipment. And that's the caveat I want to remind everybody, is when you hear drones are working great, I would ask, well, what was your disease pressure in when you use the drones? Because that's where I worry about is I'm going to get the calls when we have high disease pressure pushing the system. We did see, because of that, we limited the yield impacts, but we did have some neat data on frog eye and tar spot moving forward. And hopefully as we continue to collect data moving into 2025 this season, we'll have some more information coming from that. And now I'm going to pass it off to Kirsten.
Yeah, thank you, Darcy. And I can just start by saying that, we've done a lot of similar research to what Darcy's group and a lot of the Purdue teams have done, comparing application equipment, comparing carrier volumes on drones, comparing locations in the canopies, and we've seen very similar results. And so what Darcy's presenting is also very similar to what we are seeing in Kentucky. And we've been researching drones in Kentucky since 2019 because our small fields in Kentucky that are surrounded by trees, we have a lot of fields with different elevation changes, especially as you get into central and eastern Kentucky. This is a really important research area for us because there are fields in Kentucky that if they are going to get a fungicide application, it might only occur if a drone outfit is available. And so this is really important to us that we are able to optimize these applications. And so Darcy, if you want to proceed, I can talk a little bit about what my specific research area for this talk will be. This is a picture that was given to me courtesy of Bayer Crop Science. This is actually a field in Pennsylvania where they were doing a drone application carrier volume trial. And so you can see that there's some differences in carrier volume, but if you hit advance, I'll show you that what really sort of Bayer and I started talking about was these streaks in the field are showing, you can see the green lines in between those red arrows. That's the down and back of the drone application pass. So all of that tar spot that you see in between where those red arrows are pointing, that's the overlap in the drone. And so that swath width is not wide enough to cover the whole canopy. And you're seeing the effects of not having an optimized swath width as you have big streaks of tar spots in this field. And so this really prompted a lot of questions for us. And I have a graduate student that's looking at this now. So Darcy, if you want to go ahead and advance. One of the things we're doing is we're working with our ag engineers and the Kentucky corn growers. Darcy mentioned the swath gobbler. We have a lot of research using the swath gobbler now. And you can see down there, you were running that tape along the ground, you're flying the drone over it. And if you hit advance again, you can see sort of what that looks like. You just fly the drone over it. You can do it a bunch of times really quick. It gives you a lot of data very quickly. But we're also seeing that we have, if we like a T40, we had a T40 flying. If you look online, it says that your swath width might be 30 foot. But what we were finding with our data for the T40, it was really more like 20, or if you wanted really optimized data, probably more like 15 foot. So that's also another reason that, when you have disease pressure, you can see those gaps pop up, is because unless you're doing this type of testing on your own with your own unit, you might not know that you're not able to use that full, the just programmed out of the box swath width for your drone. If you want to hit advance. So this is something that my student had talked about, and I love that Darcy already talked about the chrome coat paper and the PTSA dyes and all of those types of things, because those are the things that we are also using as well. So you can see in that middle image, we use that phytochrome paper. We actually use big stretches of it so it mimics an ear leaf or the leaf of corn, and we put it on the corn leaf itself. And one of the things, like Darcy was saying, is we were trying to see, like, are you getting any of that wash effect? You've all seen the handlebar mustache that kind of goes when you fly the drone, right? So are you getting any of that wash on the undersides of leaves? And as a spoiler alert, if you hit advance, the answer is no. We're not seeing that under the leaf. But what we wanted to do was, based on what we were finding with the swath gobbler, our drone was about, optimized, like with the best coverage, was about 15 foot. So in that bottom picture, you can see there, we put spray cards, these chrome coat spray cards, all across the canopy. on every plant, so that whole 15-foot was covered. And then we also took leaf samples with our PTSA dye that was in there that fluoresces in a fluorometer. And then we took some leaf samples across that swath width too, so that we could look at both spray deposition and spray coverage. So how much of the carrier volume is deposited in the canopy and how much of it actually covers the leaf surface. And then we did that at 2 different spray heights and 2 different spray speeds. And our spray speeds, I fully understand, these are way lower than any commercial drone applicator is going to fly. But we did it just to try to see if there was an effect, right? So if we're spraying slower, what are we getting? And so if you go ahead and advance, we can show you some of our data. So this is going to be deposition across, so this is that PTSA dye across that spray width. And so you can see that, we're getting it across there at different, all of our different heights and our different speeds. The deposition is pretty good. But if you look at that 10-foot at 19 feet per second, so the fastest that we're flying, you start to see higher variability. And if you advance, we can show you kind of what that looks like. So this is what it looks like across the swath. So our plot position, the number 3 would be right under the center of the drone. So what you see is that you're actually getting more deposition over at one edge of the plot in that plot position 6. And so then we looked at it as the total of how much is being deposited, and you can see that on that edge of the plot is getting a lot of that spray solution. So the fungicide, everything is like ending up on one side. And when I show this to farmers, I always ask, okay, obviously this is drift, but how fast do you think the wind was blowing this day? And I always have them guess, and like they'll guess like between 10 and 15 miles per hour. And Darcy, if you hit advance, our wind speed this day was like, it averaged about 3 miles an hour. So it's like nothing. That's nothing. And you're already seeing all that movement. And so this was really sort of alarming. And so if you advance, our next thing that we looked at was the coverage, right? Like these would be the spray cards, or how much of the leaf is being covered. And at our faster speeds, you're seeing reduced coverage. So we're not seeing the level of coverage that we are when we fly a little bit slower. And so that's also alarming to us too, when I know that 19 feet per second is actually real slow compared to what a lot of the drone applicators are flying. And so if you keep going, we'll show you, we went back to the swath gobbler with this and then just started flying under a lot of different conditions. And so you see those solid bars, that's going to show you the percent coverage. And then the little dotted bars is showing you, sort of the fines that kind of hit on there as well. But this was just a couple of, as we were flying it, we had wind gusts of 6 miles an hour. And at 6 miles an hour, you can already see that shift in the spray pattern, right? So it's all moving to the right. It's not staying over the center area of that drone. And so that's a little bit alarming. And if you hit advance one more time, we had a gust of 10 miles an hour. So again, nothing like 15 or 20 miles an hour. This is just like a 10-mile-an-hour gust. And it just shifted that whole spray pattern all the way over to one side. And so this is really important to think about, that our drones are not heavy aircraft. They're not going to be sort of our ground equipment. They are going to be much more prone to these pattern shifts that we see even under lower wind speeds. And so this is going to really affect optimization of some of our applications. If you hit advance again. So this is something that we really are going to look at a little bit more closely. It was alarming to us that the faster we sprayed, the lower our coverage in the canopy. And we are seeing these spray patterns. I mean, you've probably seen it too. If you're watching a spray drone and there's any wind, it'll just start moving. It moves a lot easier than in a lot of our other application methods. And so in Kentucky, we are going to need to use spray drones to get applications on in a lot of areas. So we really need to understand how to optimize these spray swaths. And like we showed, is that if you don't have a lot of disease pressure, maybe it's okay. But that picture I showed you of the tar spot shows that if you do have disease pressure, it's going to show up and it's going to tell. And so that's why we continue to do this research. Go ahead, Darcy.
Okay, thank you, Kirsten. And I was just going to show an image that we had here at Purdue also on tar spot. So you can kind of see understanding your spray swath is really important because you can see where the green is where we sprayed across the field in the different hybrids, but you can see definitely in two different machines where we striped the field where the coverage is not there. And so unfortunately, we now have a disease that I'm going to, remind you is going to tell you how great a coverage we had. It's going to tell you how that swath width looks, and you can actually assess how far in the canopy it goes, because if that leaf is not protected, this disease is going to find that canopy that isn't protected, and you're going to see it. Just a good way to assess if it's working, because if you got leaves that are protected, you can see they look pretty clean to the ones that didn't get the coverage. So we even see this in our ground equipment. But just as a reminder, we have a disease now that's not going to be as forgiving as some of the other ones. And so when we think about that, there's a number of considerations we need to think about for determining effective swath width. I mean, you're going to understand your model and your platform. Where do we need in the application height and speed, droplet size, carrier volume, all the same things we talk about in all the other spray equipment, but we really need to think about the winds and the tailwinds and that canopy and how we're going to spray in those environmental conditions that may shift how that application goes during that day. And again, you can do things like modify your spray plan so you can bring it into 25 width versus the maximum spray width and try to adjust that once we learn what that effective swath width is. And then, and some of the things, and I guess we're coming to an end, and I know you got questions in the chat. I guess the common questions is, can I spray any pesticide using a drone is one we see a lot. And then first and foremost, you need to see if it prohibits aerial application. So if that wording is there, you can't legally apply that product. And then each state may have more state-specific regulations to follow. And I just want to remind you on that carrier volume, because a lot of our fungicides do have some of those minimum gallons per acre. And so if the minimum says don't use less than 10 gallons per acre, you're going to have to slow it down to get to that coverage level. And understand, is that coverage actually the coverage level that you're spraying at? And then these regulations are going to continue to change. So just keep an eye out. And I think as new products come online or we get new pesticide labels come out, they might start having more information on drone use within those products as well. And so finally, I borrowed this from Tommy Butts on some of the things, spray drone widths are highly variable. So anything and everything can influence that effective spray width. A failed application is a wasted application in my book. We need to pattern test it and understand the things. Find a setup that works for you, flight height, nozzle, adjuvant package, and stick to it. And I say, we're still beginning. We're in the beginning stages of understanding all of this. But again, that's something to think about. And this technology continues to move faster than we can. Sometimes it takes us over a year to just get the spray drone approved to fly with the FAA. So again, we're continuing future research on all sorts of things and looking at these newer models and updates to software and things like that. And just understand, know if you're going to move into looking at adding drones, know the limitations and spend time optimizing them so you make sure you're getting your bang for your buck and using them. You're getting the coverage you need and it's targeting what you want to do in that crop canopy. And I just say, stay tuned. And I think we have now time to turn it over to questions. I would do want to reference, Crop Protection Network has a lot of information available. The efficacy tables I talked about in the beginning, how to identify diseases and evaluate diseases and severity levels is also available there. And then finally, here's your CCA credits. And I guess we can open to questions and answers.
Thank you both so much. It was really detailed. I learned a lot about, I had not heard much about drone application. So everyone listening, please type in your questions in the question and answer there at the bottom of your screen. And I'll just start reading off the questions. So first question was, I guess, why in the world would you use a drone applicator for like a lower price commodity when you could cover a lot more acres, either with a ground rig or aerially? So I guess a little bit of the economic analysis and different types of application methods, whichever one of you cares to respond.
I can answer this question because I'm in Kentucky and it might be your only option. We have small fields that you can't get big ground equipment into. And maybe these fields are so small or have trees or have hills and things that airplanes aren't going to fly. And so this is going to be one of the things that, in some of these areas, this might be the only way to get an application on. And there's a lot of fields in Kentucky that's the case.
Very good. Next question was the comparisons based on droplet sizes aren't apples to apples. Will you shoot for smaller droplets with ground or backpack rigs for a better comparison?
I guess we're still using our fines for droplets in our ground rig and backpack, so they should be pretty comparison. And we don't have the rotaries on those drones, so they were more similar nozzles that we use on both pieces of equipment.
All right. Next question was, does the height above the canopy play a significant role? Did it specify, but maybe droplet size and disease management, if you could answer?
But I would say the height, or I can start, the height's gonna dictate how wide you're gonna get in the canopy. So yes, but there's a certain minimum you gotta fly for the drone to stay afloat. But yes, bringing it down to 10 versus 12 feet will help, and that'll help with the drift as well. But it's understanding what that means if you're gonna spray at that height. What is the canopy coverage? Go ahead.
Right. And so we actually have some data, and we only looked at closer to the corn because we want to be close to the corn. That tightens up your swath width, like Darcy said, and increases your efficacy. So we looked at 7.5 and 10 foot off the ground. We did not see differences in coverage or deposition with those two heights, but we didn't look at it any higher.
Thoughts on spraying with the rows versus across the rows?
So Darcy's probably gotten this question before too. I have gotten this question. My grad student's going to look at it this year. I know I've talked to others. I don't know of any data. Darcy, do you, that's looked at it? I think we're going to try to answer this, at least preliminarily this year.
Okay. I'm not sure because it's got an acronym in this question, so I'm hoping you know. It says, what do you know about DJI being banned in the US? And did you test Hylio drones?
Well, moving forward, we're not going to be allowed to purchase a DJI drone, but we already had them in the system before the banning. So I think until they tell us we can't use them, we're going to use them. We do have a Helio that we'll be moving towards and use that a few times but it all keeps changing on what's available and what technology is available. And some of these restrictions may limit our choices significantly, especially at the university level, or if it's a federally funded grant.
Okay. Just another question, like, what do you think are the biggest limitation to using drones for fungicide applications?
I think it's really understanding your actual coverage and how far you're getting into like this spray, your actual spray width, and making sure we're getting coverage. And just because you can do it, if we're not getting the right coverage in there, if we're not getting the right rate, then we're going to be in trouble. Even if, if we're spraying and we're really only getting half the rate of the product we want, that's, and we need a full rate to manage the disease, then we're going to lead us to other problems that we don't even get into on fungicide resistance or other things. And we're not getting the coverage we need to maintain that yield protection when the diseases are there. And so that's the other side I'll come back to is, there's a lot of fields that probably didn't need drones, especially in soybeans in Indiana, didn't need a fungicide application. So that's, make an informed decision if you really need to use them. But
yeah, and I'll just add on to that. I just think it's really important to think of your drone is going to be another piece of field equipment for your operation. And so you need to treat it like that. You need to maintain it. You need to understand it. You need to do the work to optimize all of the settings to make it work as efficiently as it can for you. And so it's not, I think there are some people that think drones are an easy option for an application, but it's no different than a sprayer. It's a piece of equipment that you have to optimize and work on, and it needs to work when you need it to work. And so if you treat it like every other piece of equipment that you put the time and effort into, I think it will be more effective for you.
Sounds like it's able to get into maybe small, like you say, smaller fields or areas within fields that are more difficult to access with it.
yeah, so we have an example like where we do both. When we try to spray, we spray the same day, but that night before it, we had 2 inches of rain drop. So the ground equipment had to wait a few days to get back in and spray, but we were all set up. So we went and the drones went, but that was a demonstration of where the drones have a little more flexibility sometimes when environmental conditions may not allow the equipment to get into the field.
Haven't thought about that. Question, I'm not sure if you guys know, because it sounds like a label question. Do you consider a drone a helicopter when considering label directions?
I don't think it is. I think it's considered an unmanned aerial vehicle, right, Darcy?
Yeah, I think it's a very specific one, and that's what, I don't think our labels are caught up to that.
Yeah.
So then I don't, it depends, I guess, if, as you got a label that says no helicopter application, is that it, versus aerial or no aerial? I don't know if I've seen one. Well, mainly I see no aerial application is what.
And another question was, is there a maximum wind speed for drone applications?
You have to read the label. That's for the pesticide that you're applying, not the drone.
Okay. What a great question. So just curious if there's a disease threshold for each disease in a crop where the drone or aerial application would be feasible and practical. So,
I guess it goes, well, a threshold, so I guess I'm just, any fungicide application is what we're looking at, right? And so I'm gonna come from, you need to be scouting and monitoring and using our other tools. So we have some maps that we're tracking tar spot, and we have a tar spotter app to kind of give you a prediction of weather conditions. But then here in Indiana, we're seeing where I can find, it in the lower canopy before it reaches the upper canopy. And the goal in corn is to protect that ear leaf and above for that yield potential. So there is time to, if I'm finding it and we're approaching VT tassel silking, that's where I'm going to say, yes, it's probably time, especially if the conditions look conducive, that we need to think about a fungicide for tar spot and even gray leaf spot. If we see it creeping up the canopy, maybe we need to target that application. There is a window for optimum applications. And again, that comes back to the diseases of concern. So gray leaf spot, generally BT to R1 has been the optimum, and when we're treating it, we're going to go for it. Tar spot, we might open that window a little later because the disease comes in a lot late, could really ramp up later in the season. So anywhere from VT to R3 is the optimum window for, we've looked at fungicides in general on using that for controlling tar spot. I think at frog eye, there's a little, if you know your varieties, and we didn't even talk about that, but if you know your variety is susceptible and you're finding frog eye and you're approaching reproductive stages, maybe then that might trigger that it's time, there's a time to, yes, we might see it blow up in a susceptible variety. But and then it comes into layering all the other factors. What is the susceptibility of your hybrid or variety you put out there for the targeted disease that you worry about? And then with the costs and, and the value of corn and beans dropping, the question is really get the return on investment. Is there yield potential protection there? And there's some tools that are available on Crop Protection Network to try to identify yes or no on if we need a fungicide for the season.
I don't see any other questions coming in, and we're approaching the end. So I would just want to thank you again for a really interesting webinar, and just to let everyone know you will receive an email when the recording is available. And so thank you both so much. Our next North Central IPM Center Pest and Progress webinar will be on Wednesday, May 21st, again at 12:30 Central and 1:30 Eastern Time. And it's going to be on the use of lasers for weed management. And Hongbu Tsang from Middle Tennessee State University is going to talk to us about that. So we will hopefully see you all in a month. Hopefully everyone scanned your CCA credits. If you have any problems, feel free just to email us after the program. So thank you all and have a great rest of your day.